afternoon. My name is George Love. I'm with Texas State Technical College. This is being filmed at the Waco campus. My contact information is scrolling below, and you should be able to reach me by email or phone at any time. Today we're doing a video on saw operations. I'll be showing 3 different saws, their feed and speed, how to square work, how to check square on work, how to do the stock stop, and how to secure the work before operation. First off, let's start off with safety. In this case, there are crush hazards underneath the yellow and the red. I've turned this saw on. This saw has an automatic off feature right here, and it will turn itself off as soon as it reaches the base of its destination. This machine has both a feed and a speed selector. The speed selector is up here on top. This machine has a speed selector for 1, 2, and 3. This has a chart in the back for number 1 is for tool steel, stainless steel, hard, cast iron, alloy steels, and bronze. 2 is for mild steel, and 3 is basically for non-ferrous and wood and soft aluminum, not hardened aluminum, I guess. If you'll notice, I've turned the 0 again to straight forward. This is all the way off. So if I were to pick this head up, you would see that it has 0 motion as it locks into place. This saw also has an automatic down feed. In this case, the selector to turn it off and on is a little valve. This is off. This is on in line with the valve, just like most normal plumbing items. This is hydraulic with a shock absorber inside there. I'm going to start it off all the way at 0. If you'll notice, the 0 position where it's tightened all the way down is straight forward. Now I'm going to adjust it. This is in line, so it should be lowering. I'm going to adjust it up, and you can see the head slowly feeding down. Now if the machine were running when it got to the bottom, the switch would actually turn it off. Click. For the purpose of this demonstration, my program has made up a chart. It calls out material and dial number just to keep things very simple. Aluminum is 3, brass is 3, steel is 2, tool steel. We have suggested that they not cut tool steel on this machine. It's too lightweight for that purpose. In a standard clamping situation, we would use the rotary clamp here that locks into place, and then you can screw it in like this to lock and make my cut. But if I were doing something where I needed to do like an angle or a large piece, it's sometimes handy to use a secondary clamp like this. When doing so, always make sure that you run the clamp down. Check it. If you'll notice, my blade guide here is going to hit. So before it hits, I'll stop it and move my blade guide back. My other option, of course, is to readjust my clamp. If it's possible, I may want to turn my clamp further out and lock it into place across the top like that. I just need to check the line of my blade, make sure it's not going to cut into my clamp, and also that I'm going to be able to allow my stop to come all the way down. In theory, it should clear. In reality, every now and then you'll find that the blade guide will hit the clamp or the stock stop or something else along those lines. You need to keep an eye on that. If possible, I try to keep this as far in as it will go. The shortest distance between this is the best setup for cutting a straight path. All right, the next section that we're going to do is I'm going to show you the effects of feed on the angle of cut for this. What we've got here is a standard 1x1 aluminum block. Remember, we've got a feed selection and a speed selection. I am not on the aluminum selection right now, but I am on the steel selection. That's where we normally leave it. For the purpose of this demonstration, I'm going to take this and I'm going to write slow and fast. I've got my slow and fast down there, and I'm going to cut the slow one off at the slower pace, the fast one off at the faster pace. Notice that my machine machine feed control is down, and I'm set at 0 right now. I'm going to go on and lock my part in. Forward by hand, lock the speed control, turn it on, and now I'll go on and set my feed. This one calls for a 3. So I'm just going to run this up so that the 3 is in line with the body of the saw, and I'll start the feed on it. Notice coming down at a pretty controlled pace. If it's coming down faster than I like, I will turn the handle on here. Like when it gets close to it, I'm going to grab the handle and I'm going to stop it from impacting and bouncing up and down, because that's bad for the blade. This is all the way in as small a throat as I can make on this saw, and that's okay. It does an okay job. Alright, it is starting its cut. I have just a little tiny bit of pressure on my hand. Now it's inside the cut, so I'm letting it go. Remember, when it gets to the bottom of its cut, the automatic stop on this Vectrax will shut it off. And it stopped. Going to turn the feed to 0, raise it up out of the way, unclamp my workpiece, and break off that last little bit that was hanging at the bottom. That was the slow side. I'm going to do the same on the fast side, but I'm not going to control my feed so much. I'm actually going to let it go over what I would consider a normal speed. My feed was on 3 for the last one. I'm going to turn this one up to 8 so that we can see a difference in cut. And again, I'm going to control this hand coming with my hand. I'm going to control it when it impacts the top of the part. It's in the cut. I'm going to let it go now. And this is basically feeding as fast as it can. I'm going to take this out of the saw. We're going to go over to the inspection table and we're going to take a real close look at it. If I were concerned about the surface of the part, I would worry about the jaw eating into that. And I would use something like these. These are sheet metal, sheet steel. Some of them are soft aluminum, but in general, the purpose of these is to protect the vise, protect the part from the vise jaw. Some of these are a pretty aggressive thread on it. I'm not concerned with that. So for the purpose of this conversation, I'm not going to use that. I'm just going to clamp it in there directly. All right, we'll be doing the deburring operation here. One of the things I like to do is I like to keep the angle of my file as close as I can to the top. Now, having said that, I've set this up the wrong way. I'm left-handed. I like to keep the angle of my file as close as I can to parallel with that. That helps me to knock that edge down faster. Notice that I'm doing a light file on these, but I have a heavier burr. on this corner, so I'm going to do a real power file on these. And that's this side. On this side, I'm going to do all three at once, just for a time saver. And then I have to flip it over to get the bottom. Now that it is burr free, I can measure it properly. Okay, we have our fast and slow sides. I'm going to do my slow side first. All that I really want to know is the angle of the cut on this. And so I'm going to take my machinist square. I'm going to lay my handy dandy compass head out of that, and then I should do it this way so I can lock it down when I'm on top. There we go. I'm on top. I'm going to lock it down, and I'm going to get my measurement. My measurement right here is about an 87 on the slow side, and on the fast side, it is about an 84 or 84 and a half. So I've got a couple of thousandths difference in here. Let's say that 3 thousandths doesn't make as much difference. 3 degrees of angle rather does not make as much difference when I am milling something. However, when I talk about the total amount of material that I'm losing there, 1 degree over 1 inch is about 17 thousandths. If I have a 3 thousandths difference in here, I'm losing approximately 51, 52 thousandths total material. 50 thousandths on one piece is not a big deal. 50 thousandths on 1,000 pieces suddenly is a big deal and it's worth a lot of money to you. So pay attention to your cuts. The faster feed gets done quicker, but leaves you more of an angle.